Hey there YouTube, Chemistry Tutors here. This is the second series of Redox Chemistry, and this is the episode Introduction to Oxidation Reduction. What is redox? Redox reactions include all chemical reactions in which the oxidation state changes. All redox reactions include electron transfer from one species to another. Redox is a combination of oxidation and reduction. Oxidation and reduction are both two half equations or reactions. Neutralization reactions, however, are not redox reactions, since essentially neutralization reactions are transfers of protons and not electrons. Some definitions we need to learn are oxidation. We can define oxidation as a loss of electrons or an increase in oxidation number. We'll get to what an oxidation number is shortly. Reduction is the gain of electrons or decrease in oxidation number. Oxidant or an oxidizing agent is a species in which accepts electrons from another species or oxidation number decreases. Reduction or reducing agent is a species which donates electrons to another species or oxidation number increases. An oxidation number is a hypothetical set of numbers assigned to atoms or ions in a substance according to a set of rules. Oxidation numbers. We can assign a set of rules to assign oxidation numbers. The rules. Number 1. The oxidation number for an atom in its elemental form is always 0. For example, hydrogen gas is 0. Oxygen gas is 0. Zinc metal is 0. 2. The oxidation number of a monoatomic ion equals the charge of the monoatomic ion. For example, copper forms copper 2 plus ions, hence the oxidation number for copper 2 plus is 2 plus. 3. Hydrogen has two possible oxidation numbers, +1 when bonded to a nonmetal, and -1 when bonded to a metal or formed a metal hydride. 4. Oxygen has two possible oxidation numbers, -1 for all peroxides and -2 for all other compounds and molecules. It's most likely when you do oxidation numbers with oxygen, it will be -2. 5. The sum of all the oxidation numbers is 0. 6. The sum of all the oxidation numbers on a polyatomic ion is equal to the charge on the polyatomic ion. So, for an example, what is the oxidation number for S in SO3? Well, we can do a bit of algebra. We can label S as S. We can go plus, and since the oxidation number for sulfur trioxide in oxygen is -2, because it's not a peroxide, we can label -2, and since there's 3 oxygens, we can go -2 times 3. So we've got now S plus -6 equals 0. We can do some algebra to eliminate, to just singularly find what S is, and S winds up being +6. For a second example, what is the oxidation number for chromium and dichromate? We can do a bit of algebra. Note that there are two chromiums in dichromate, so we need to divide in the third line of working, divide by 2 to just find what the oxidation state is for one Cr. In our third example, what is the oxidation number for P in PO43-? And this winds up being +5. What is the oxidation number for Mn and MnO4-? And it winds up being +7. albeit you might find that different imine compounds will actually give different oxidation states for imine and a lot of the transition metals, and this is a particular property that the transition metals have. That's why they have the name transition metals, because they transition from different oxidation states. And the fifth one, what is the oxidation number we're looking for Ba in BaO2. BaO2 is actually barium peroxide, so you put a -1 instead of 2, -2 for barium peroxide, and barium peroxide, in this case, barium has a +1 oxidation number. When we can use oxidation numbers to we can assign them to reactions or species in reactions to identify what is being oxidized and what is being reduced. It can also tell us what the oxidant and reductant is. For example, in the first reaction, we have iron plus oxygen equals Fe2O3, or forming iron oxide. The oxidation number for iron has increased from 0 to 3, plus 3. Iron is being oxidized, and iron is the reductant. And this is what we can tell from these changes in oxidation numbers. The oxidation number for oxygen has decreased from 0 to -2. Oxygen is being reduced, and oxygen is the oxidant. Note that there must always be a change in oxidation number, and there always will be in a redox reaction. And again, an oxidation must always occur, and a reduction may always occur. You'll never get 2 oxidations or 2 reductions, since one species must give up electrons, and one species must accept electrons. Another example, KClO3 equals KCl plus oxygen. The oxidation number for Cl has decreased from +5 to -1. Cl is being reduced, and Cl is the oxidant. The oxidation number for oxygen has increased from -2 to 0. Oxygen is being oxidized, and O is the reductant. And it's pretty straightforward.